Hey robot makers, hope you're having a good day so far. So do you want to develop programs using ROS and Python? Don't know where to start? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. So this is part 3 of the Learn ROS with Me series. Okay, let's get over to our keynote and make a start. Okay, just arrange my screen a little bit here. Okay. So the session goals for today, we're going to continue our look into ROS, the robot operating system. We're going to look at some ROS concepts again, the runtime, the environment, and the tools that are available. We're going to dive into some nodes, look how we can manage nodes in ROS using the command line. We're going to look at topics as well. Topics is a really important concept in ROS, so we're going to have a look at that. And packages, how we can build packages using ROS, so we can have many nodes in our system and bring them all up at the same time and selectively run them and so on. So we're going to have a demo about how to create publishers and subscribers in ROS. So if that sounds cool, stick around. And we're going to also have a look at how SLAM works. SLAM is the simultaneous localization and mapping, which is a really cool thing within ROS. And then if you hang around for the live stream, if you're watching this live, you can also have a look at what we've got in the mailbox this week. There's a few things that have been sent. I want to show you those, and we can obviously have a bit of a hangout and a Q&A. Okay, so let's get into this. So the setup process, we looked at this last week. I've added this extra little box in here. So we're going to play with ROS today. We're going to investigate nodes, topics, messages, tools. We'll have a quick look at RQT, RVIZ and Gazebo, but it's probably best if we save that when we get the LiDAR up and running, which hopefully be very, very soon. And here are some of the components that make up ROS. So I spent way too much time fiddling about with LCARs things in Keynote this week. So there's 3 different parts to this, if you like. There's the runtime part of ROS, there's the environment, and then there is the tools that make up ROS. So nodes, topics, packages, services, parameters, and logs all form part of the runtime of ROS. They're code that we can run. The environment is made up of workspaces and packages. Workspaces are essentially just folders where we store all our files together, specific files in a specific structure. And packages is how we bring all those files together in a sort of meaningful sense from ROS. Tool-wise, RQT, RVIZ2, Gazebo, TF2 and ROS2 Doctor are all parts of the tools that we can use to investigate our ROS setup. So RQT is like a node graph. We can see all our nodes in a nice graphical way. RVIZ2 is a visualization tool. We're certainly using this when we bring in our LiDAR data and we want to map the environment. We can see that. We can see what the camera can see and so on. Gazebo is a simulation environment, a bit like Unity, I guess, where you can bring in models and you can have them simulate in an environment. TF2 is for doing transformations of message types and data, and ROS2 Doctor is a way you can investigate your ROS system to see if there's any known problems that you might be up against. Okay, so next is ROS2 nodes. So what are nodes and how do we use them? So nodes are the building blocks of ROS. They can be algorithms, they can be connectors between different systems, they can be sensors, they can represent services, they can translate data. And nodes enable us to abstract really complicated systems into smaller independent building blocks. So what I mean by that is if you typically create a robot such as this one I've got here, which is a little MicroPython robot, we essentially have to build everything into the single Python program. All the controls for controlling the motors, for receiving data from the sensors, understanding where it is in the world by measuring the distances and perhaps even building up a map. All that kind of stuff we would typically build into one monolithic program. And there's a tipping point where there's too much to put into one program, and if you want to change anything, it gets complicated. So ROS helps you separate out all those different concerns into separate nodes, and they don't even have to be running on the same computer. So that means we can offload some of the more complicated CPU stuff to a more powerful computer and have more of the low-level stuff running on the robot itself. So we've got 2 commands there that we can look at. We've not actually got any nodes running at the moment, but we're going to have a look at these. So ROS node list, ROS node info. So what I'll do at this point, I'm just going to break out to me for a second, and I'm going to bring up our environment. So let me bring this up, and let me make sure that we are good to go in there. Yes, right. So if I go over here, so I've got Visual Studio loaded here. I've not got any files loaded yet, but this is following on from what we did last week, where we connected to a Docker container which is running ROS2 on our Raspberry Pi. So this little robot next to me on the desk on the overhead over here, this is actually running through this cable here, this actual instance that we're looking at right now. So so if I go on here, I can type in, so the first thing I need to do is source the folder that has all the setup for this particular thing. So if we do setup.bash, oops, source, not saucer, and that will bring in all the like environments and all the paths and so on. So we can now take ROS2 node list, and we actually haven't got any nodes running at the moment, so it's probably not going to show us anything on there. But what I can do is I can probably just I'm going to skip ahead to something we can run in a minute. So if I do think it's that, let me just run, we have to do a source again on that one, so I think it's old package install setup.bash, and then let's just run that particular package. I know what I'm doing there. So let me not bother with that just yet. I've not prepared that particular bit, that's why that didn't work there. But essentially we haven't got any nodes running yet at the moment, so that means that we can't actually see any nodes in our system because there's nothing actually live. So that's what that will actually do once we get our nodes up and running. There's also node info, so when we've got a node running, we can look at what information that node has, where it's running, and information about it and so on. So we can have those in the back of your mind for a second. We're gonna create some code that will actually make those work. So next is topics. So topics are the message transport system for ROS2. So if you've ever played around with Internet of Things with Node-RED, you probably come across MQTT, which is the MQ telemetry transport. MQ doesn't stand for message queue, which most people think it does. It's actually an IBM system, MQ. Anyway, so messages are routed via the transport system between a publish and a subscribe node. So it uses publish and subscribe semantics. It's that kind of mechanism. So a node will send out a message by publishing it to a given topic. And topics are a bit like channels on a TV. You can have different channels to represent different things. And unlike MQTT, ROS topics are strongly typed. So when you send a message, you define what type of message that's going to be, and the thing that's subscribed to that has to expect it to be in that format too, otherwise all bets are off and it won't work. So the publishers send data to a message broker, which is our ROS message transport system. Subscribers listen to the broker for any data on that particular topic, and then they can deal with that data once they receive it. So again, we can debug this by doing ROS2 topics list. Now we can actually have a look and see which, if I go over to our system over here, let's do topic list instead of node list and see what we get. And see if there's actually any topics running at the moment. So we've got two topics. We have ROS out and we have the parameter events. So they're two topics that we currently have. So I don't know if we can do info on them. Let's see if there's anything. We have to at least define which topic we want to get info on. So if I do ROS out, is that right? There we go. So currently there's nobody subscribing to that, but there's just one publisher, which is that RCL interfaces message log. So any logs are being published to ROS out. Okay, let's get back to our keynote there. And another thing that's quite cool that we can do is we can remap nodes on the fly. We can do this as part of our running program. So if we decide we want to have like a publisher node and then we want to have the exact same publisher node running, you can't have two nodes with the same name. So you can actually rename one by remapping it. And you can do that, like I say, at runtime after the program, after ROS has been started up. So that's quite cool. Okay, so next up we have topics. So like I said, topics are a bit like channels. And they can also form a path. So we might have a scan topic, and then beneath that there is a laser scan, and that's typically how the LiDAR data comes across into ROS. We have a laser scan topic. Message contains the actual data that's being communicated. So a message will have a data section, and that contains like the payload, a bit like MQTT payloads. And then we've got the publish and subscribe method, which you probably will be familiar with. But if you're not familiar with this, just think about how magazine subscriptions work, where you can there'd be a publisher like Magpie Press, and they will publish magazines. and they essentially go to a distributor. That distributor will then have a list of people that have subscribed to that magazine, and they will send them out to them. So that's kind of how that whole mechanism works there. So if you like what I do and you want to help me grow the channel more this year, please give this video a like. Drop me a comment. Let me know if you've got any experience with ROS, where you're up to, what your ROS experience is. Have you used previous versions of ROS, or are you ROS 2 and Python only? Really interested to know what your take on that is. And if you've not subscribed to the channel already, hit that subscribe button, click the notification bell, and you'll get notification whenever I go live. And I go live every single Sunday at 7 p.m. GMT without fail. So if you want to catch me on the live there, that's how you can do that. Okay, so ROS 2 packages. So packages can be C++ packages, Python packages. There may be other languages that you can use in ROS, but I've not come across them. It's mainly C++ and Python. And we can create some packages. So this is like a bit like a library of related programs. So we could have a publisher and a subscribe program, two separate files within the package, and the package can be a container for all those different things. So we're going to create some code in a minute. We're going to create a Python class to send our message on a timer. So we created at the very end of last week's YouTube video, we created a program that would send out a message. We're going to make it do that on a timer, so it does it every couple of seconds or half seconds. We're going to build another class that will listen for messages and log them, and then we're going to bundle all this together into a package and run the nodes in separate sessions. So demo time. Let's do this. Okay, so I'm just going to go over to, let me just get my environment correct. So there we go. If I go over to here, right, so I am logged into my my QB robot over here. We looked at how to do that last week. I'm actually running in a Docker container. You can see there, docker_ros2_1 is the container that I'm currently running this session from. And I can type commands like ros2 and it will accept those commands. Everything's good to go. And over here on the left-hand side, and I'm using a Mac to do this editing. So this is on the machine that's running the live stream at the moment. This is an Apple Mac, as you can see, and it's remotely connected using the SSH Remote Connect to the Raspberry Pi 4. And I can see all there on this QB1, all the different file structures that I've actually got on here. So I'm just going to exit out of that container for a second. And I'm just going to show you what we've got. We've got a couple of different folders. So there was one that's called Old My Package. That was me sort of testing out before the show. And we've got a build, a log, an install, and a source folder, which we created last week. So for me to get back into the container, there's a couple of things I can do. I can either right click over here and do execute in bash, or I can just type the same command here. So docker exec-it for interactive terminal, docker_ros2_1, which is the name of the container, and then bash, which is the shell that we want to actually run. So if I do that, did I do that wrong then? There we go. So we're actually now in the Docker container running ROS. So the first thing we always have to do is just source the environment variable. So just do that. Right, so the first thing we want to do, our Talker program that we looked at last week, we want to enhance that so that we can make it into a class. So what I'm going to do, I'm going to create a new file on here. Let's see if it'll let me do this, talker2.py. Yeah, that looks good so far. When I save this, does it have any problems? Sometimes you just have to fix the file permissions, otherwise it has a problem, but don't have any problems there. Right, so the first thing I'm going to do is import RCLPy, which is the ROS command line Python interface, and then from RCLPy.node we're going to import node, which is a key building block. Now we're going to build a class. Last time we just wrote a program. This time we're actually going to build a Talker class. So let's call this Talker. We should have a capital T really there because it's a class, and then we're going to inherit from the node from this thing in here, so we'll get all loads of extra functionality kind of for free in there. So next we need to create our initialization function, so let's do that. And in here we're just going to call, because we're inheriting from node, we can call the thing we're inheriting from's init function. So if you do super, it will do exactly that. And we want to pass in there the name of the node this is going to be. So let's call this one node test. And that's that line. And then next we need to do, let's create a counter. Let's set that to 0, and then let's log out some information. So if we do self.getLogger, this is part of the thing that inherits from node, and we can then just do an info, and we can say hello world, like so. And then what we can then do is we can create a timer. So one of the cool things that you can do in ROS is you can create a little timer, and let's just do that. Let's create timer. You say what the time period is. So these are like seconds, so half a second or 2 hertz. And then we can create a callback. So I'm just going to say self callback. Oops, we don't need the double brackets there. And then down here, let's actually create that callback. So timer callback. I'll just increase the size of this a little bit just to make it a bit easier for you to see what's going on there. Cool. And what we'll do on here, this is just going to do self.counter. It's just going to increment that, so plus equals 1. And then we'll say self.getLogger, and we'll and .info again, and we'll just echo out. Let's say hello, and then let's add to that the counter itself. So self.counter. Oops. And that should be fine. Okay. And then do we need to do anything else there? No, that's all good. Right. So then let's just create a main function. So down here, let's do main, and let's just bring in any arguments. There's not going to be by default. And we're going to say rclpi.init. So we're going to initialize with any arguments that are brought in. So that should be args, actually. Args equals args. This is one of the, when we do args, arguments, parameters, this is how we can do some of that remapping dynamically later on. We can bring that and filter it through like so. But for now, let's just create a new node. So let's call node equals talker, the thing that we just created. And then let's spin this up. So we do rclpi.spin. And spin will create the loop that the node will run in. And then after that, we just need to gracefully shut that down. So shut down. Okay. And then we've got that usual boilerplate piece of Python, which says if name equals, and then main, then run main. Okay, that is our new talker program. So if we come down here and we look in our environment, so let's go into source, I think that's in. Where did I actually put that file? Talker2. Talker2 is in our source folder. So let me just see. So I need to go into ROS2 first of all. Go into source. Have a look what we've got. And we've got Talker there. So where is... it's under first app. Let's go into first app. Go into source. And there is Talker2. So let's just do Python 3 talker2.py. I've not done the sourcing of this environment or built it yet, so let's just see what happens there. Yeah, so it's not very happy about that. And it's also, I've got a bug there, which is that should be timer callback. Let's try that. And that's working fine there. So it's done hello world as it goes through the initialization. And then we've created a timer that says every half second run this code. So it's going to increment the counter, which is this at the end here, self.counter. And it's basically just logging out hello plus the counter. So you can see there, that's running there. And we're actually just running it directly. We've not built it as a package. We've not done anything else like that. You can just run it directly. Okay, so let me just cancel that. And by pressing Control C, what will happen is it'll stop the spin. It'll drop down to the shutdown. And excuse me, then it will exit out. Now, if I run that again, let's go over here. I've got some other sessions open over here. Let me find, there we go. So this is another ROS terminal session from that container. So if we now do ROS2 node list, let's see, we've got node test. Now node test is the name of that node that we created there. So we can now see by looking at our node structure, our node is running and it can be seen by other terminal sessions. So we can see that that works. And let's do info as well. And let's do info node test. And we can see there that it's got quite a lot going on there. So it's got no subscribers. It's publishing out to ROS out any messages. The parameters, it brings those in by default. And it's using these servers. So node test, describe parameters, get parameters, list parameters, set parameters. And it's got no service clients, no action servers, and no action clients. So we can delve into all the information about this particular node. Okay, so let's go back to that other node which is actually running it, press Control C, and if we jump back and then do node list again, you'll see that it's no longer running, so it'll just return nothing. So there we go. So that's how we create a class to represent our node. So next we're going to do some interesting things. Now, before I do that, I want to show you where I'm reading all this from. So let me just load up kevsrobots.com and let me show you where we are. So I'll go back over here. So I'm on kevsrobots.com. If you go to learn and go to learn ROS with me, you'll then be able to follow along. So I've actually created these extra steps here. So last week we were looking at the first ROS program. We kind of stopped there. I'm just going to jump over to this local version of it, and we're now going to go through so the talk programmers, I think, is what we've just created there, the class. So there's all the code for that. And if we go to the next stage, we're going to create a ROS2 package, and this is going to create the environment that we're going to put all our package things into, our publisher and our subscriber. So I can literally just grab this here, copy that. I can come over to our Visual Studio environment. Let me just see where we are in the scheme of things. And what this is going to do, so ROS2 package create, we're going to create a package that's called myPy package. The build type is going to be Ament Python, which is like the build system for Python. And the dependencies, we are dependent on this RCL_py, which we've been using in our code. So RCL_py, we're going to actually define that as a dependency. If I press return there, what's actually happened there, there's a whole bunch of files and folders that have been created. So you can see there, version 0, it's done inside ROS2. And if I just have a look through here, we've now got a new folder that's called myPy package, and it's got all these extra things in. So there's another folder that's called myPy package, that's got an init.py in there. We have a resource folder. There's a myPy package resource in there. We have a test folder that's got a copyright test, Flake 8. If you've not come across Flake 8, this is a Python standard to check your code. You can actually get this running as a plugin into Visual Studio. And PEP 257 is another standard. PEP is the standards body for Python. And again, that will just help define some tests in there. We've then got package.xml. We'll actually edit this in a minute. You can see there the dependency that we specified, RCL_py, has been defined there. We've got some other things in here as well. So the name of the package, the version that it's currently at, the description, we need to put in there a package description. We need to update our maintainer, so it's not just root at to do. It's whatever your email address is, and then what kind of license that you're specifying here. Is it a MIT license, BSD, GPT, or whatever? And then we have some dependencies in there, and then it's going to export it as an Ament Python export. So that's something we will update in a second. And there's also a setup.py, which has the same kind of information, but down here, more interestingly, it has these entry points. And we'll have a look at what entry points are in a minute as we actually get into this, but that's something that we will edit. The rest we can probably leave alone. Okay, so now one of the things I have discovered in here, if I go back up to this myPy package and I create a folder in there, let's just call it test.py for a second, it comes up with this unable to write file thing there. If I just move me out the way, you'll see what it says there. Unable to write file, VS Code, remote, blah, 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 no permissions. So if we go back to our instructions on here, it should be able to tell us that what we need to do there. We basically just need to fix the folder permissions on there. So let's just grab that, copy that, and then let's go back over to Visual Studio into our, let me just click cancel on that for a second. and then let's just run this command here. So what this does is it's changed the mode, the file permission. 777 is like full access. R just means do this recursively on all subfolders and files, and the thing that we want to change is my py package. So if we now do an ls, you can now see my py package is green, and that means that I can now go back over to that test thing I was trying to create then. So if I just do test.py, it creates that, and we can save the contents of it and so on. And if we go down here, go into within the container my py package, we go into let's see, oh, test is there, so there you go, test.py, inside my py package, test.py is there. So if I just type in hello world, and then we just cat what's in test.py, you can see hello world is there. So we just need to remember to do that whenever we create new files or folders. We just need to check the permissions are correct, otherwise it'll throw up that annoying message. Right, okay. So in our Python package that we've just created, if I just come over to here and I just drop down into this area, you can see we've got all those different mypy package, the package.xml, the setup, and so on. We can actually at this point do colcon build. Colcon is our collaborative construction tool which will build things. Now it sometimes comes out with this error, this standard error, and it says on here that there is a problem. So what's the problem? Oh, it's actually saying that there's a problem because I've just typed the word hello world. Maybe we just need to do that. Save that and try building it again. See what happens now. It usually takes about 3 seconds for it to build. Boom, finished. Now it can sometimes throw up a package error, and the reason it brings up this package error is because there's a problem with pip. Pip is the Python build system. So if you have this same thing where it says one package had a standard error problem, you basically just need to run these things. You downgrade pip. So you just do pip install setup tools equals 58.2.0, and it'll just downgrade it to a version that we know works. Don't know why that is, but that's the workaround there. And if you find that you can't actually get pip to install, you can just run this sudo apt update and sudo apt install pip-y, and that will install the pip system. It's this setup tool dependency package that seems to cause the problem. So that's how we do that. We've run our fixed permissions, and what we're going to do now is we're going to add a dependency to our package.xml. So we're going to create some messages, and the topics I said were strongly typed, and one of the types that we want to use is a string type. So to use the strings we need to bring in the standard messages. So I'm just going to copy that. I'm going to come back over to our mypy package folder, and what I'm going to do on here, I'm going to find that package.xml, and where we've got dependencies we're basically just going to drop in the extra dependency, standard messages. Save that file. So that's saved, and let's go back over to the next step. So we've done everything on that page. So next we're going to create a publisher. So this is going to publish some messages to the ROS topic that we choose, and we can have a look and see how that whole publishing and subscribe method works. So what we want to do is we want to create a publish file. So let's do that. We can use touch. If you've ever used Unix before, if you say touch and then a file name, it will create an empty file with that name. So let's just grab that there. So I'm just going to copy that. I'm going to come back over to our environment, and let's just, so I'm in a folder that's called mypy package. So if I just show you the structure there, mypy package, that's in the root. There's also another folder that's called mypy package within that, and this is the structure that they use. So here we go. So touching this will create a new file that's called pub.py. So pub.py is there. So let me just type in something and try and save it. See how we're getting that error message again about the permissions. So it says on our instructions there, the next thing you need to do is just change those permissions to fix that particular issue. It's a real pain to do that, but this is what we need to do. And we can go back down here and just paste that in. That's going to fix that up, and we try and save that now, everything works fine again. So we've just fixed the permission on that pub.py. Okay, so let's create the contents of pub.py. So I'm just going to copy and paste this. I know this code works, so it just helps a few issues if I type this directly, but I'll talk you through everything that's going on in here. So let's just go and paste this in. Let's just uncomment that out. So we're bringing in RCLPy, which is the ROS library that we use in Python. And then from rclpy.node, we're going to import node. We did that in our talker class a minute ago. And we're also going to bring in this standard messages string type from the messages sub module. This talker node, we're going to extend this. We created this before. We're going to extend this a little bit. So we're still doing a node test. We're still having our counter. And we need to create a new thing, which is a publisher. So the publisher needs 3 parameters. It needs a message type. So we're going to use a string message type, which we've imported from up here. The contents, the payload is just going to be hello. And I could say hello live stream audience. And then the last thing is the buffer size. So we could actually overload our robot, our ROS, by sending too many messages at once. By defining this buffer size, we're kind of saying these are the number of messages we expect to be able to hold at any given time. So we're specifying a value there of 10. For now, we just need to know that that's what that is. It's just a buffer, and potentially we could send too many messages and it'll just let some messages go. We'll never actually receive them. So next we're going to create a timer. So this is a little underscore in front of it. Don't need to worry about that. That just it's just part of the Python way of programming. Python, unlike Java, doesn't have public and private data types and functions and methods. So we use these underscore and double underscore to do the same kind of thing, but it's more of a bodge than anything else. So we're going to create a timer, and we use the create timer function, which is part of Node. And we again just say half a second, we want to publish hello, and publish hello is this callback down here. So that refers to the name of the function. You don't need to include the sort of double brackets. It understands how that works. And then the last thing we're going to do there in this initialization is just get logger and just say publishing message. We could say publishing message has started, something like that. Okay, so then we have a publish hello, which is our callback. So whatever we call this here, we have the same name here. So we're going to create a message object. We're going to make that from string, which is what we brought in up here. So this is a ROS message type, and message.data, which is part of it's like the payload. We're going to say hello world, and again we could just say hello audience, such as that. And we can say self.publisher.publish and publish the message that we've just created. So that'll work every single time this timer calls that callback. So every half second it will run this code over and over and over until we press Control and C. So our main function, and this is outside of the class, this will just say if there's any arguments, pass them through. If not, define them as none. We're going to initialize our RCLPy. We're going to create our node, and it's going to be called talk, which is our class here. And we're going to spin that up as a new node, and then it's going to run and run until we do Control C, and then it will shut it down gracefully. And this boilerplate at the end is just a way of saying, if you've not defined what the function is that you're going to run, then just run main.py. So let's save that. So this is called pub. So if I now go into my py package, I can see now that there's a Python program that's called pub. So let's just run pub and see what happens. So it doesn't like hello live stream audience. It has to have no spaces. So let's just do an underscore and try that again. There we go. So publishing message has started. Now look on there, it doesn't do anything else. You can't see all those hello live stream audience messages because they're being published to the topic, not to the screen. So we need to create another half of that to actually see it. But we can use another part of ROS, which is the, if we go back over to our second terminal over here, do ROS2 topic list. Let's see what topics we have. We can see that there is a hello live stream audience topic that we've just created. And we can say echo and then hello live stream. Actually, let me If I press tab, sometimes it lets you auto-complete that live stream audience. And what we should see is all the data that's being received on that particular topic. So hello audience is the data. So we could actually change that. So we've also got the counter. So self.counter, like so. So let's just let's leave that running. That can be running on one terminal. We can go back over here. We can press Control C, and then we can just run it again. And if we go, it's the same counter. It was counter underscore. Oops. So I just need to update that. Run that again. There we go. So that's started. If I now go back over to our second terminal, we can see there that it says hello audience. And we're not incrementing this. So let's fix that up. So let's just say self.counter plus equals 1. Let's go back over to the thing that's actually running it. Control C, run it again. So message publishing has started. And if we go back over here, we can now see hello audience, and then the counter is incrementing. And if we wanted to make that a bit better, we could just put a space after it like so. So you can see there we've got 2 different nodes running at the moment, and we can actually start up a third one if we wish. If I go over to here, and I've started up a third terminal. We need to do source again, so let's just do source ROS humble setup.bash. Again, that just brings in all the environment variables, makes everything work. And if we say ROS2 nodes node list, we should have 2 nodes. No, we have 1 node, sorry, because the other one isn't running yet. That's just using the ROS command line tool. So node test is the thing that's publishing out everything. So there we go. And if we jump back to here, so we can see that that's publishing has started, and this is just continuing to echo out. So this isn't a node in itself, it's just more the ROS2 command line, which was ROS topic echo, and then the name of the topic. Okay, so that's the topic. Just get to my next page. So, right, so we need to do a bit of maintenance now. Let's go back and stop that one running just for a second. Control C. So we just ran them directly from the command line. We didn't actually compile the package that they were in. And to compile the package properly, we need to update some of the package information. So if we go back over here to our, let me see, setup.py. So currently this console scripts hasn't got anything in it. And an entry point is when a package is run, it can have certain entry points. It can have certain scripts that it knows about. So we need to add to this our pub and our sub, our talker and our listener. So we need to add that and update it. So if we go back over to our Google Chrome, our tutorial, it basically says on here, what we need to do now is update our setup.py to include the entry point for our code. An entry point is the name of the scripts that are available to run within the package, and are shown if we do ROS2 run my package. So if we ran that currently, it would show anything. There'd be no entry points in there. So we need to update our setup.py from within our my package folder, and then we need to add this entry point. So we can basically just copy that wholesale. And let's see what actually that means. So let's go back over to here, and let's just replace this wholesale, paste that in. So what we said on here is the console scripts contains a list which is pub, which is our publisher. So my package pub.main. And we've also got that talker, which is the my package talker main. Now, I'm not sure we've actually got that in the right place at the moment. So what I might have to do is just grab that file from our other place, talker2. Let's just grab that, oops, and move that into the right place. So I've got 2 screens on here, so that's why that looked a bit weird. And let's just rename that back to talker.py. Okay, and I probably need to just fix the permissions on that because we've fiddled with it. So let me just jump back a folder. If I just up arrow, I'll find that that command there that just fixes all the permissions. I can see now that it's fixed because it's turned green. So what that will then say is we've got 2 things that are interest, pub.py, which is this, the name is pub, and that equals mypackage.pub. So mypackage.pub, and then within pub, we want to run main, which is the main loop, which is, if I go back over there, it's going to run this code here. So that's what we want to do in our setup.py. Let's save that. And what we can now do is we can build our package. So let's go back over to our instructions, and it says, right, we can now build our build out package. I think it should be our using colcon build. Do this from the root of the workspace ROS2 mypy package. So we can do that from within here. So if I do pwd, that tells me the sort of current working directory, which is ROS2 mypy package. That's where we want to be. And if we do colcon build, it will now build all of that package. It will read that setup.py, it'll read that package.xml, and it will construct a new version of the package. So that's the package built. And to actually use the package, we have to remember to source it. Sourcing is this annoying thing that we need to do. So if I show you where the packages are, if I do ls, you can see we've got a build, an install, and a log, and a source folder. Actually, we've not got a source folder, but that's fine. So we've got build, an install, and the package itself. So if I go into the install folder, and I do ls, you can see here we've got all these different local setup utilities, local setup.bash, .ps1, .sh, and we also just have setup.bash. I'm going to use the setup.bash. If I do ... and I say install source, and then install, and then setup.bash, that will essentially run that bash file there, bring in all the correct environment variables for our particular package that we've just built. Right. So now if we do ROS2 and we say run, and then if I just type my p and press tab, it knows about this. If I press double tab, it will now show us what we can potentially run in here. So listener, pub, and talker. So if I say run pub, like so, it's now going to run that part of the package, that publisher node from within our package. So ROS2 run my package pub. So we've created our own package, we've created a publisher within that, and we can now run this using ROS2's run command. So this is really cool. So what we need to do next is create a subscriber, because currently we're just publishing data and nobody's listening to this. It's just sort of going into the wind. Okay. So let me see what else we've done. We've had a look at topics and how to investigate that using the ROS2 topic echo, which is what this next bit says. It says if you want to see the messages themselves, you can use the echo topic. So ROS2 topic echo, and then the name of the topic that you're publishing to. So in the tutorial that I've written here, it's just hello, but we've just tweaked that for live stream audience. Okay, let's go to the next page. I'm going to create a subscriber now. So we need to do the same thing, do touch, and then we just need to fix the permissions. So let me grab that. Let's go back over to our environment over here. Let's just Control C out of there, and then let me see where I am. I need to be inside the mypy package folder with all the other, all the other things. So pubs there. So if I now do touch mypy package sub, I'm inside the mypy package folder. So let me just do that, touch sub. You can see now that we have the sub, but it's not green. We can't actually write to it properly. So we need to run that that annoying thing, which is change mode. So let's just grab that, Control C, go down here, paste that in. I should really be following my instructions properly and then run it from there. So this is saying change the mode recursively to 777 for the mypy package folder. So our pub is now able to be written to. Now this is pretty similar to the code that we've just written for the publisher. We're just going to change the publisher to the subscriber and change a few extra little bits on here. So let me go over to our tutorial. I'm going to grab the code that's here, and then let's just walk through what this actually does. So let me just grab all that, paste that into our new sub, So once again, we're importing RCLPy. We're also importing node from RCLPy and importing the node class. And we're also importing the standard messages, message types, and we're using that string because we published a string, so we need to use a string for the subscriber. So I'm calling this class listener. We're inheriting the node, which is from RCLPy. And in our initialization, we're just going to run node test. Let's call this node listener test. Listener, there we go. We're going to set our counter to 0. And the subscriber needs a couple, I think it's actually 4 parameters, not 3. So we need message type, topic name, the callback, and the queue size buffer. So we're going to say self.subscriber equals self.createSubscription. The string is the message type. The topic that we want to listen to, so I think we call that something else on here. So that's hello live stream audience. Let me just copy that from pub. And let me just publish that, stick that in there. So hello live stream audience is the name of our topic. The callback, that whenever we receive a message on that topic, we need to do something with it. So self.callback is what we're going to define down there. And again, once the queue size buffer is 10, like we defined before. And what we're also there going to do is say self get logger. We're going to say subscribed to the hello live stream audience topic. So we defined a callback there. So whenever we get a message that we're listening to on our topic, we need to do something with it. So this function here, define callback. So whatever we call that, we can give it any name that has to have the same name there. We use self because this is a class. And then message is, we want to do something with the message that we actually receive. So self get logger info message.data. So we're simply just going to log this data out. So we could actually do something a bit clever, like say this is what I got, and then message.data. And then once again, we have a main function outside the class, and we pass in any arguments, define them as none if we're not going to get any arguments. We see rclpy.init, any arguments that have been passed in equal the arguments. We create a new node, and we're going to call this one listener, using the listener class that we've just defined. We are going to then spin up that node, so whatever we call that needs to be there, and then that will run and run and run until we press Control C. And we're going to shut that down once that Control C has happened. And again, just in case we want to run this from the command line without running it through ROS package, we can just do the if name equals main, then run main. So let's save that. Let's come down here and let's run this actual thing. So let's go into my Pi package. I'm going to make sure I've got the publisher running on 1. So let's go down here. Let's just clear off this. And let me go to the correct place, which is my Pi package, and I'm just going to run Python 3 and then publisher. I'm just going to run that so that that's just publishing some data. So if I now come over to here, which is our code that we're just going to run, let's do Python 3 and let's do the subscriber this time. So here we go. So it says subscribe to hello live stream audience, and then this is what I got, and then the message that the publisher is sending out, which is hello audience 4740 blah blah blah. So you can see there we're just listening to the data and we're just logging it back out to the terminal, but also to the ROS logging system. So we can redirect these logs to completely different computers. You can have that on a different thing there to debug. You can have a syslog server, that kind of thing, to do something with these logs, to investigate them. So we're just doing info nodes, and info nodes are just kind of throwaway messages. You could set different levels of logging. So you could say only log critical errors. You could say only show me warning messages. So it's not an error, but it's maybe a warning. And then info is just, something that the programmer wants to sort of show themselves. But you could probably dial that out just by setting the logging level. Okay, so we've got a few things going on there. Let's go over to our middle terminal here. Let's have a Let's have a look at, I'm trying to get that one there, node list. So we have 2 nodes running now. We have the listener test, which is our subscriber. So node listener test, That's the first one, and then node test is actually the name of our publisher. Really, we should change this to, I don't know, publisher node, something like that. Node, like that. Okay, so once we restart that, it'll have the correct name and we'll see in there. Right, so let's just stop those two because we're just running them directly from Python, but not from within the ROS packaging system. So let's just jump back to the ROS2 mypy package folder, and we're then going to run colcon build once again. And we also need to update the setup.py with the new entry point, which is the subscriber. So where we've got this talker here, we just need to add in an extra thing, which is the, let's just call it listener equals mypy package dot, and then sub, and then main. So whatever we've called that particular package, so sub, and then the main function within that. And that should do us okay. And then we need to come down here and then just do colcon build, and that will tell us if there's any problems. Again, it takes about 3 seconds on this Raspberry Pi 4. No problems at all. Once we've built a package, the next thing we always have to do is source the install and setup.bash to bring in those new settings just in case anything's changed. And if we now do ROS2 run and then mypy package, we do double tap on the tab, we can see we've got the listener, the pub, and the talker. So that's because the sub is called the listener. And if we say run listener, I do that. So that's now subscribed to the hello live stream audience topic, but no messages are coming through yet because we're not running this anywhere. So if we go back over to a different thing over here, let's just get into the same folder. Let's just do source install setup.bash once again, and then let us go into, and then let's do ROS2. I always keep typing ROS3, ROS2 run mypy package, and then double tap tab twice, and then let's just run the publisher. So let's do that, and it's now publishing messages. So if we go back over to our other terminal there, we should start to see the messages come through. So why is that not working? Pub. I think it's because we called it talker, maybe. Let's try that. No, it's not that one. It must be pub. I would have thought we would have the messages logged out. So they are being logged out. They're just not being logged out to the terminal there. So we can come over here. We can do ROS2, and we can look at the topic, and we can echo out. Let's do topic list. We should see a couple of different things there. So hello live stream audience. Let's do, right. So the reason we won't get anything through on our subscription, let me just check everything's right there. So the publisher is publishing to hello live stream, which is what we want. The subscriber is also listening to hello live stream audience, so that should work. I just wonder why we had the hello node there. And then if we just do hello live stream audience, we should get any messages that are coming through there. Oh, I need to do echo, not list. That's the next thing, sorry. Like that. So what have I done wrong there? Because we should be getting, the publisher should be sending out messages there, and it doesn't seem to be doing that properly. What would be going wrong there? So let's have a quick look. So we've subscribed there. Hello live stream audience, that looks correct. And then on the other one, node test. So let me check on here that we are all working on the same thing. Right, so talker is actually the one that's running. So let's just stop that one for a second, the publisher. Let's just go back over to our setup.py, because I've essentially just pointed at the wrong Python program. So instead of being talker there, let's do pub. You probably already spotted that one. In fact, let's get rid of talker altogether. So we've just got pub equals pub main and listener equals sub. There we go. Let's save that. Let's go back down here, colcon build. And then let's just run these again. Right, so this time we can run our publisher. So publishing messages, let's go over to our subscriber. Let's just run that again. So instead of a listener, do we call it, oh, we did call it listener. Run that. I'd expect to see the messages coming through, and we're not seeing them come through. So why is that not doing it? So we're publishing it on the timer, the message is being sent out there. What's going on there? Why is that not logging out? So the subscriber should be running the callback and saying this is what I got, because we saw that running okay. And the publisher is also running on a timer and pulling that out. So does the subscriber need to be running on a... It's not a timer, that looks fine. Yeah, not sure what's going on there. With it being a live stream, it's very difficult to troubleshoot these things, but maybe this is the time to look at ROS2 Doctor. Is it ROS2 Doctor? ROS2 Doctor. So let me make sure we have all our sourcing correct on here, because that sometimes can throw things out. So let's do install setup.bash. Let's run the publisher on here. So ROS2 run my py package pub. Okay, let's go over to our first one. Let's just clear that, and then let's do source, because we've rebuilt everything, install, and then setup.bash, and then let us run ROS2 run my py package, double tap, and this time we want the listener to run. There we go. There we go. So we're getting Hello World. Cool. And Hello World is another piece of code. So let me just see where that's pulling that from. So it's actually running the talker, so rather than the publisher. So let me just go and check our setup.py again. That's weird. So maybe we just need to build that package again, or do we need to get rid of one of these other files? So why is talker being run? Talker.py. We haven't specified talker.py down there, which is weird. What did I run when I sent the publisher work in? I said pub, and on here, which is the listener, let's just have a quick look in our listener code. I want to make this work. I don't like things not being working. So the listener is sub. Now is that because I've got the same name, listener? Yeah, so listener isn't listed there, but it is listed as part of the package. So listener is then running the sub, and the sub is then printing out everything that we expect. So that should be... It's weird that it's printing out Hello World. I don't understand why that is, because we're only subscribing to the Hello Livestream audience, and the Hello Livestream audience one should be, if we echo that out, let's see what happens on there. Oh, so we've just come back to this terminal here, so what we need to do is get into the ROS2 folder, get into the my py package, source the install setup.bash, and then we can then run that again. So couldn't it determine the message type? So let's do ROS2 echo list. This is all part of the troubleshooting thing with ROS. Let's just list the topics we've currently got. So we've got hello. That's really weird. Why is it sort of still remembering that? It's as if it's remembering this from a previous session. So maybe that's what actually is going on there. So Dale's saying, what are you having trouble with? Oh, that he's asking Adam there. Cool. So I previously had the hello topic being published to by some other code, which was in the old MyPy package, which was on here. I basically just got rid of that before the live stream. So there's another folder on here that's called like old PyPy package. I thought I got rid of that so that you couldn't actually get there it is, old MyPy package, and it's as if it's running code from this particular build. So if I go over here and I go to the MyPy package on here, there's a publisher and a subscriber, and they've got the hello. You can see there hello, and it's as if it's running that. So that's in the old MyPy package, but I'm not in old MyPy package, so I'm very confused. So what we can perhaps do then is just come out of all the instances. Let's just come out of that and come out of that one. So we're actually now not running any Docker interactive terminals, and let's log back into all 3 of them again. So let me just up arrow, or come over here and just right click and say execute in bash, which is the same thing. And if we now just do that source opt setup.bash, then go into my MyPy package, which is in the ROS2 folder, and then do source install setup.bash, and then do ROS2 run MyPy package, and then let's run the so I think what's happening there is it's registered the old MyPy package and it hasn't like deregistered it. I think that's what's actually happening there. That makes a lot more sense, I think. So let me just see in our MyPy package what we have in there. So we have publisher, subscriber, talker, and test. So pub and talker, I think, are the old ones that have been registered, and we need to sort of get it to deregister those from the ROS environment. I don't know how you do that because I've not done that before. So I would have thought it would be to do with when you compile the package. What we perhaps could do is we can change the package name from MyPy package to something else, so it's not a duplicate of that. So if we come and let's backtrack, and let's actually rename this. So if we do move MyPy package, and let's call this KevPy package, something like that. Go into KevPy package, excuse me, and then let's do the same again on there. So let's do move MyPy package, KevPy package. Let's do colcon build. It might complain because it's looking for specific paths and things. Yes, I thought it might do that. So what we'll have to do is go back over to the 2 configuration files in KevPy package, which we now just messed about with. So the package.xml will be looking for KevPy package. Let's save that. Let's go to the setup.py, change the package name, there we go, to be KevPy package. And that all looks good there. Let's change that to be KevPy package, KevPy package. Let's just try and build that, see if that fixes everything up. What's it complaining about there? The install folders don't look quite right. So MyPy package, we probably just need to rename that to be KevPy package. I should have created it with the correct name. You won't have this problem if you're starting from scratch. This is just because I'm trying to do this kind of mid-flow. The log should be fine. The install should be fine. Let's get rid of... Let's leave that in there. That should be okay. And let's just try building it one more time. It's still complaining about them. I think that'll be fine. Right, so if we now do source install, and then setup.bash, and we do ROS2 And I think we can list out the packages. So is it package list? And it will tell you all the packages that it knows about. So it knows about quite a lot of packages by default, but what we're looking for is kevpi package. Let's scroll down to here. Kevpi package is there. Okay, so let's do ROS2 run kevpi package. And then let's double tap. And it doesn't seem to be happy with that. So why would it not be happy with that? Is it because, I mean, I could just start again and just cut and paste everything in there. If you run this, it'll work fine. It's because I've messed with it. That's what's going on there. You could see the publish and subscribe work fine. I just wouldn't recommend, if you're trying to do this, creating the package and then creating the package again with the same name in the same system. I think we need to basically just wipe that and start again. So what I've done on here, the part of the way that this Docker container is set up, is that on the Raspberry Pi itself there is a ROS2 folder, and I've remapped that folder so that it's inside the container, and that means when I exit the container and then go back in, it still has that same ROS2 folder system. Otherwise it'll be completely wiped and you get a fresh container, but because of that, that also means it's kind of bringing along some baggage with it from the previous time I was running this. That's a bit annoying, that. So let me just have a quick look and see if there's anything else we needed to cover off on that particular thing. But we actually had it running publisher and subscriber. It's just the previous version of the package. So there we go, build, and then we source it. So that's everything that we've got as the next couple of steps. So if you wanted to follow along, you can carry on from the first ROS2 program that we created. The Talker ROS is the object-oriented version, the class version of the Talker, and then we created a package, we created a publisher, and we created a subscriber. Okay, let's get back over to our keynote, and let's carry on. So I said we would briefly talk about how SLAM works. Now this is going to be really cool when we get our LiDAR up and running. We can simultaneously localize where our robot is, and we can also map at the same time. It's a really cool algorithm. We can talk about how this actually happens. So SLAM stands for Simultaneous Localization and Mapping, and it's a collection of algorithms used in robotics for navigating and mapping at the same time. So it's really clever that we can map a location, but by also mapping it, we can figure out where we are within that map. And then if we move, the map essentially stays the same, but our position on that map changes. And when I say essentially changes the same, this is where some really clever machine learning stuff comes in, because we can detect roughly if things have changed and then update our position within it. So we use LiDAR. You can also use sonar or other sensor data. You can actually do it just from a camera, although that's a bit more difficult, but you can do that. And that helps build this three-dimensional map of the environment. We have a mapping node in ROS that we can use for that. And then we have localized, we can have a SLAM node that will do all that complex machine learning to figure out where we are. So the LiDAR will create a 3D point cloud. So it doesn't actually build a solid map. It will, as it sends out a laser beam that way, it puts a point to say the distance between us and that particular point over there is, you know, so many meters. It then moves a fraction as it's spinning around continuously, like another degree. It will then get another point. So what you end up with is a load of different dots around the robot. So if you're in a square shape, you'll see a square map if you visualize that in RVIZ 2, for example. And it builds this, what it calls an occupancy grid, a grid map. And the occupancy grid map is then used to localize our robot and navigate through the environment. And SLAM can use additional sensory information such as inertial measurements from an IMU. It can bring in camera images to enhance that data even further. And in fact, the more that you have, the more accurate your position can be. So this generates an environmental map, uses our sensors to refine that map. And then our robot is localized in the environment by tracking its motion compared to that map that it's built up. So how this works in reality, there's this process that SLAM uses. So we've got our IMU, we've got our telemetry information about our gyroscopes, our accelerometer, our digital compass, possibly even like a GPS. We've got our sensor data, in this case a LiDAR, but it could also be sonar information. or other sensor data such as that. And we can also have a camera. So our robot has a camera on the front of it so it can see the environment. We can also bring in that data and use that as well. And what they then do is they then go into a feature matching node. And the feature match will look for things like corners. So if you have an environment that's completely white and completely smooth, for example, a camera will have a real difficulty localizing itself because all the information is the same. What it's looking for is edges or structures or colors that are the same. And then this actually is how an optical mouse works. So if I just grab my my mouse off my desk without knocking everything over. This is a reasonably modern mouse, and it has a laser in there, and that essentially sends out a bit like a LiDAR, but it actually just lights up the environment underneath it, and there is a camera that looks to see what that environment looks like. And then when you move the mouse, it then compares the previous image with the new image and tries to match up features. So this is why optical mice don't work very well on glass, because glass is just reflecting back everything. It works best on a textured surface where it can see things and it can find those features, match those features, and then work out what the difference between the two is. So feature matching works both from a camera perspective, from images, from a LiDAR perspective. It's essentially triangulation of all those different points and figuring out where you are and if you've moved a little bit, and it can find those edges, those corners, those features. So they all then feed into the pose estimation. So if we have cameras, we call that visual odometry. If we've got our IMU, our other sensors such as my robot, they're having a fit, we might have some wheels that have got encoders on them, so we can get that kind of odometry as well. All that will then feed into this pose estimation, and pose means what position our robot is in this environment. So is it upside down? Is it pointing left or right? What degree is it at? Is it moving? All that kind of information is held in this pose estimation. We then have a couple of extra steps to refine that pose estimation. So loop closure, it will track to see, has the robot been in this position before? And if it has anything changed? Can it refine the position that it's in if it recognizes where it's been before? And then bundle adjustment prevents drift. So if you go for dead reckoning on a robot, so you've got some encoders on your robot's wheels, it's moving forwards, but it doesn't really know, has it actually moved forward? Has the wheel slipped? If you just use that kind of IMU data and odometry data, you'll find over time your robot will drift on the map. It'll look like it's moving to different positions, and that's because of little errors and inaccuracies in the real world location versus the data that's being sent back from these sensors. So all these bundle adjustments, loop closure, all feed into the pose estimation to make a really solid position on our map. So that's the sort of background process that goes on with SLAM. So feature matching matches between different images, tries to see what orientation, what location you are based on those images. The feature matching extracts features. So this is like we've done before when we did object detection with the Jetson Nano, where we detected like I don't know, a SMARS robot versus something else. That's all part of feature detection. And in this case, we probably just want to detect edges. And do we recognize those edges in that configuration? And then from that, we can then infer direction of travel, orientation, so on. So feature matching involves extracting these features from an image, finding the same features in another image, and then working out where we are. This is done by comparing the features such as intensity, color, shape, texture, and so on. And once the features are matched, the pose can be then updated, or the location on the map can be then estimated. And by combining these over time, we can then use that SLAM algorithm or algorithms to build up a much more accurate map of our environment. Like I said, optical mice use a similar kind of method for tracking where it is and how far and how fast it's moved in each orientation. That just uses like an image. So pose estimation is the process of estimating the position and orientation of the object in 3D space. Combines computer vision, so if it's a camera, machine learning techniques to define those, to detect those and match those features, and then determine the 3D position of our object from an image or video or LiDAR data. Pose estimation can then recognize objects, estimate the poses in a scene, allowing for applications such as augmented reality, robotics, virtual reality, and so on. And TikTok and Instagram actually use these kinds of feature detection when you put a filter on. It happens so commonly that you wouldn't think it's quite an advanced AI, but you get your TikTok on your phone and put like, I don't know, like a animal ears on or change your complete face. What it's doing is it's recognizing features, recognizing the pose and position of them and the scale, and then putting the filter on top of that. So a lot of actually advanced AI machine learning going on Instagram and TikTok. And then algorithms detect features in video and images, look for key points, edges, and then machine learning then uses those to identify the objects and estimate the pose. So that's pose estimation. Loop closure. Like we said, this prevents the drift. Did I get those two wrong before? Bundling and loop closure. So the process of recognizing when a robot has returned to a previously visited location enables the robot to accurately map the environment and improve its navigation capabilities. And by recognizing the previous visited area, it can more accurately understand the layout of the environment and accurately determine its location. So this prevents the drift from the IMU, the telemetry, from the odometry data, and those little inaccuracies build up over time. So certainly if you built a robot, you've had it working on like a surface and the wheel slips slightly, you'll find that it can't quite turn 90 degrees. It might be like 89 or 91 because of that slippage. So that over time means that each time it does that and it slips a little bit, you get more and more drift. So loop closure can prevent that. And then bundle adjustment is that process of refining the camera poses, the location information, and minimizing those reprojection errors of estimating 3D points and onto the observed 2D points. So it's comparing what it can actually see with what its map is and updating that over time. And the algorithm used for that is called the least squares sense. This is like a statistical process. So if you previously detected that there was a wall over there and it's like 1 meter, and then you've come back to what you think is the same position and you check again and it's ever so slightly out, this least squares statistical algorithm will then correct for that. So it's like a really quick way of optimizing that. So the goal is to optimize the estimates of where the camera's position is, the robot's position in the 3D points, to obtain the best fit solution. And these kinds of things, mapping, route planning, are really quite advanced robotics topics because there is continually better and better algorithms being developed all the time. So it's quite a task to keep on top of these. But there's quite a few that you can just treat as black boxes within ROS, and you can just trust that it works and just reap the benefits of that. So it's an iterative process. It'll keep doing that until the reprojection errors are minimized. So it just happens behind the scenes. Cool. So if you want to join me on Discord, you can head over to kevsrobots.com/Discord. If you want to get help with specific issues, I know quite a few people have reached out to me on Facebook Messenger, on Instagram, on TikTok, on YouTube comment sections. If you want to get the best help from me, Discord is probably the best place to do that. I check it at least once a day and just see if there's any messages from people where they're looking for help. And if you're a subscriber, a member, you'll get kind of priority attention from me as well on that. So the other thing I've updated this past week is the How It Works section. So I've been building up the resources on kevsrobots.com. So if you go to kevsrobots.com/resources, you'll find a glossary of terms, and I'm building that up all the time. And you'll also find individual articles about how various different things in robotics work. So you can see there I've got quite a few already. We've got how pots work, potentiometers. We have how encoders work for like motors and wheels. How SLAM works, which we just covered off there. How MEMS works. MEMS is amazing. I can't believe there is such tiny mechanical things. How they work in accelerometers, gyroscopes, and digital compasses and so on. We've got potentiometers, how they work, encoders, which is like, it's different than the motor encoders. These are, what did I even put on there, the encoders? I don't know, you have to read the article to figure that out. It's rotary encoders, that's the difference. And then there's SLAM, which is the simultaneous localization and mapping, which we've just done, and MEMS, which we've looked at there as well. So there's quite a few of the different ones to look at. Go over to kevsrobots.com/resources/how_it_works if you want to jump straight to that, and let me know what you think. If you want to follow me on social media, I'm on TikTok at Kevin McAleer6. I'm on Instagram at Kevin McAleer. I'm on Twitter at KevsMac. and I'm on Mastodon, kevsmac@mastodon.social as well. So why not say hi if you're on any of those platforms? Give me a follow. That really helps me grow the influence and get the channel out there, get people building robots, which is what I love. And if you want to help support the show, and so many people have been really jumping in on this recently, thank you so much for that. It makes all the difference. So you can support the show by doing a super thanks. If you're watching live, you can do a super chat right now. Let me make sure we've got super chat switched on. So let's go over to here, switch that on now. So yep, there we go. That's switched on. We've also got our buy me a coffee as well. I need to rearrange where that is. It's kind of covering up my kevsrobots.com logo. You do a super thanks, that's if you're watching on replay. Super chat is if you're watching live and you want to help out. And if you go to kevsrobots.com/coffee, you can buy me a coffee. It's just a link to buymeacoffee.com. And if you also want to help out, you can join the YouTube membership program. It's either or, I guess, or if you want to be really generous, both. And the YouTube membership, once you've clicked subscribe, there's a join button that appears, and you can click that and just join the monthly membership fee. Again, it's just the price of a coffee. So there we go. All right, let me just get back over to here. My mouse is all over the place. So I shall now tell you the supporters. I had to update this twice before the show because we had some extra people join very recently. I wanted to make sure they got a shout out because they've been so generous as to join. So let me just switch off that widget just there. So supporters, we have Justine Lutz, we have Roland, we have, let me pronounce this right, Zugaldia, is that? Zugaldia. We have Bill, we have Mark, David, Shroomy, Derek, RGS. We've got Roland again, he was very generous enough to do that twice in 1 month. We have Bill Bernard as well. Bernard, sorry. Members wise, we have Tom Weiser, we have Shemi, we have Steve Phillips. Thank you guys so much for that. And then YouTube members, we have, so it's Shay Sadiq Basha. I had to go and check how you pronounce it, Shay, because I thought it was Shake, and it said it's Shay. So I just checked that before I went online. We've got Jeff Ford, we've got WB Peabody, we've got Jeff Moore, we have Bill Hoy, we've got Dale from Hybrid Robotics, we've got Hans from Cheerlights, Michael Stockdale, Jose, Johan, and we have Jean-Paul Jolly, and we have Tom as well. So thank you everybody who's supported the show. Really, really helps. I thank you so much for that. Okay, let's get back over to there. And I think that is everything for the replay part of the show. Yep. So let me go back over to me. So this is part of the video where if you're watching this on replay, I'll say thank you so much. Thank you so much for watching, and I shall see you next time.